Hello everyone. Let's go over some problems about functions given by formulas, using the formulas, interpreting them, graphing them, finding net change, and finding average rate of change. So in this first problem, we have a tank that holds 50 gallons of water, and the tank is draining from a leak in the bottom, which causes the tank to empty in 20 minutes. The tank drains faster when it is more full because the pressure on the leak is greater. Torricelli's law gives the volume of water remaining in the tank after t minutes as V of t equals 50 times 1 minus t over 20 squared. So first we have to sketch the graph of V of t by plugging in these different t values. So I only let my students use scientific calculators. So let me go over how I would do this on a scientific calculator. So there's a couple of ways that you could do it. I'm going to use the TI 30XS model here to show you guys. So one way would be to just plug in one number at a time. So you could do 50 times 1 minus, and then I'll do the first number, 0, divide by 20, close parentheses, square. Okay, enter that, and I'm getting 50. And then basically go back and edit this formula by going back up to it, grabbing it, hit enter, and then go in here. And then for the next one, just put 5 where 0 was. Okay, so this kind of thing works fine. And then if you need to replace that with a longer number, use the second insert. You see the little green insert right here? So you can do second insert, and then you can type in a number in front of the 5, like 10, for example. And then if I want to get out of insert mode, let me do second insert again, and then I could overwrite that with a 0. Okay, so you can keep plugging in numbers like this, that's fine. But if you have a calculator that does a table, that's really great. So you see the table button right here? So we're going to do table, and then you can put in your expression in terms of x right here. So I already actually had it in because I was testing it. But if that wasn't there, let me see. How does it look? Oops. Let me try clearing it and entering it so you see how it looks when it's not already in there. Table. Oh, it just keeps... Okay, so the point is that you have to enter the expression using x. So when you get over here to where you want to put the x in, right there, you're using this button down here that has the x and some other variables on there, and then you click x. All right, and then after you enter that formula, it's going to give you these questions right here. So you have to tell it where you want to start. So I'm going to start with 0 for x, and then how big the step size is, and I am going to do 5. Okay, and then I'm going to keep it on auto and just go ahead and hit OK. So now see, it's giving me a little table of values here. And I'm not loving the fact that they're in fractions because I wanted to put these on a graph. So let me go back to the table, and I'm going to change this very first variable right, or the very first number right here, 50. I'm going to enter it with a decimal point. So 50 point, oops, that was 5.0. Let me go back one. I'm going to do 50.0. And that's just going to force it to calculate it as decimals. Okay, I know it seems kind of dumb, but this actually works. You could also use this little fraction to decimal button right here above table. But I think since we want to do it on every single one, this will be easier. Okay, so now they're coming out as decimals. So we can see the values there. So let me go ahead and draw on the graph here. So the first one was 50. All right, so, I need to zoom out a little bit. So the very first one here is 50, and that's for 0, so I'm putting that right here. Oh, Microsoft is trying to interpret what I wanted, and what I wanted was just a blob. Okay, so the next one is going to be 28.125, and that's for t equals 5. So 28 point, so I think this is 25, 26, 27, 28, so right around here is good. Just kind of approximately there. And then for 10, it was 12.5, so boop, 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 right in the middle here. And then for the next one, I'm going to start scrolling down. So 15 is 3.125. 3.125, right around here. And then for 20, it should be down to 0 because that's how long it took the tank to empty. Yep. Okay, so that's down here. And then we're just going to connect these as best as we can with it looks like a curve, like a parabola. So, and I know the formula was actually quadratic, so it should look like a parabola like this. Okay, I didn't quite connect those perfectly, but it doesn't have to be perfect, but it shouldn't be too horrible. Okay, I don't think I really did any better the second time there. I'm using this big fat stylus, so hopefully your pencil sketches will look better than this. All right, so that was the graph. And then for the next one, what is the net change in water volume between 5 and 15 minutes? So what you want to do here is you want to have your y value or your function value at the second time, and then minus your function value at the first time. Okay, so we're finding the water volume at 15 minutes, and then we're subtracting the water volume at 5 minutes. So it's the newer value minus the older value. Or it's the second value here minus the first one. Okay, so it's always the end minus the beginning. All right, so then going back to our little table of values here, I think, so it's going to be the 15-minute one was 3.125, and the 5-minute one was 28.125. So this is 3.125 minus 28.125, and then you can throw that into a calculator, and you're going to get negative 25 when you do that. Now, does it make sense that you get a negative? Actually, yeah, the water was dropping. So this represents the fact that the water dropped by 25. I think the unit was gallons. It dropped by 25 gallons between 5 and 15 minutes. So the next question is related to this. What is the average rate of change in water volume between 5 and 15 minutes? So for average rate of change, it is just your slope formula. So it's y2 minus y1 over x2 minus x1. So the change in the y values, which we already just calculated, over the change in the x values. Okay, you got to make sure that you get them in the same order. So for this one, it doesn't matter whether you do end minus beginning or beginning minus end. They just have to be in the same order in the top and the bottom. So if you're doing 15 minus 5 on top, then you got to do 15 minus 5 on the bottom. But just remember, it's the y values on the top and the x values on the bottom. Or to say it another way, it's the dependent variable on the top, function values, and then the independent variable on the bottom. So we already calculated the top in the last part. That was negative 25. And then the bottom is 10. So this is going to be negative 2.5. And if we needed units for that, it would be gallons per minute, because the top was gallons, and the bottom is minutes. But they didn't actually ask us for that, at least not explicitly. But this represents the fact that we're losing an average rate of negative 2.5 gallons per minute. Okay, so that was this problem. And let's look at the next one. After a certain medicine is injected into a patient, the concentration C of the medicine in the bloodstream is monitored. At time t in minutes since the injection, the concentration in milligrams per liter is given by C of t equals 30t divided by t squared plus 2. So first we're going to sketch the graph, and we're going to plug in these t values. Now these t values are not equally spaced, so this is going to be a little bit trickier, but we can still do it using the table. So let me go ahead to my table thing here. Go back to table. I'm going to clear this formula, and I'm just going to call it X because my calculator has an X button and not a T button. And I don't actually need to use parentheses around the top there to protect the multiplication, because multiplication and division have the same priority. But if you're a little worried, you could use the N over D button, which does a fraction, and then do it like this. So 30x, and then I'll use the arrow key to go to the bottom. And now for the bottom, you definitely need to protect it. So get it in parentheses, or you can use this n over d fraction mode where it is automatically protected by being all in the bottom like this. Okay, so either put the bottom in parentheses or use the n over d fraction mode. Okay, so now we're going to start at 0, and then for steps, I'm going to use 0.5 because that's the first step I need, and then I'll just scroll to the other values that I need. Okay, so the first one, oh right, it's this thing again with the fractions, so let me go back table, and I'm going to enter the last number, I guess, the 2 as like 2 point or 2.0. You can also use the F to D fraction to decimal button, but that will only do it for one number, I think. Okay. Okay, so now it's done it for all the numbers. Okay, so our first number here is 0. So let me go back to my chart here, and I'm going to put in 0 for the first t value at 0. So right there. And then the next one, so at 0.5, it was approximately 6.7. So 0.5 is here on the x-axis. All right, so I need to go up to 6.67, so about 2/3 of the way here, like right around there. Okay, and then the next t value we were asked for was 1. Okay, so I'm scrolling down to 1 here, and that's giving me 10. So I think 1 is right here. Oops, that is a really bad dot. Okay, that's good enough. The next one is 2. So that's 10 again. All right, so that's going to be here. And the next one is 5. So it's all the way down here at 5.5 repeating. So let me come down and look at my x-axis again. 5 and 5.5 repeating. So right around, oops, that's 6. Hold on. Right around here, I think. Okay, and then for the next one, it was 8, I think. So I should remember, I'm the one who picked those weird points. So 3.63 and 8. So 3.63 should be right around here, I think. Okay, so those are our points. So starting at the origin and then going up, and then kind of, oh, that looks terrible. It shouldn't have so much waviness. Maybe I'll do this with my mouse instead of my big fat stylus. And then kind of going through those 2 points and then just kind of tapering off to the side. Wow, this is, I can do this better with a pencil, but okay, please accept my efforts here. Right, that's basically it. So this is what's called like a surge graph. It surges up really fast and then it tapers off slowly. Okay, what is the net change in concentration between 0 and 2 minutes? So you're just going to take your concentration at the end time and subtract your concentration at the beginning time. So it's always end minus beginning or new minus old. And I'm just going to grab these values from over here. Let's see, what were they? So 2 was 10, and then I think 0 was 0, right? So this is going to be 10 minus 0, 10. Okay. Now, what was the average rate of change between 0 and 2 minutes? So this is just your slope formula. So we're doing our second y value or our second function value minus our first function value, and then over our second x value minus our first x value. We already did the top, and the bottom is 2. So this 10 is just coming from up here. So this is going to be 5, and then they did not give us, they didn't explicitly ask us for units. If they did, the top is in milligrams per liter, and then the bottom is in minutes. So this would be milligrams per liter per minute if they wanted to know. So I'm not explicitly asking my students to do this usually, but if you're doing it for like a science class, then you would want to put that. Okay, So these are the final answers here. Next question. The rabbit population on a small island is observed to be given by this function. There are a lot of rabbit questions in math textbooks. It's because this actually did happen on some islands. I mean, Australia is a pretty big island, but there were numerous species that were released there and then just like kind of exploded in population. I think it happened on Guam too, and some other places. So the rabbit population on a small island is observed to be given by the function p of t equals 120t minus 0.4 t to the fourth plus 1000, where t is the time in months since observations began. So first we're going to sketch the graph again. I'm going to go to my calculator, and I'm going to go to table, clear. Okay, and I'm going to put in 120x minus oops, that's too many points. Delete. 0.4 x to the fourth. I'm going to use the arrow key to get out of the exponent there. Okay, and then plus 1000. Okay, so enter. And then I'm going to start at 0, and my step is going to be 2. Okay. All right, so the first value is going to be 1000, and then it's 1233 at 2. Okay. So it's 1000 when we started. We landed on the island. We let the rabbits off the ship. Why did we do this horrible thing? People did a lot of crazy stuff in the 1800s. They did not understand ecology and the environment and like how fragile it was. So 1233.6 was the second one. They just thought, if we can do it, then let's do it. And we all cursed them bitterly. Now, looks like it's going up. So let me scroll up a little bit. The next one is 1377.6, which these are evenly spaced, so I think it's going to be over here. And then 6 and 8, 1201.6. Oh, look at that, it's going down. So 1201.6, maybe we're going to survive this rabbit apocalypse. And then lastly, 321.6. Yep, it's going down. 321.6, so all the way down around here. Okay. So I think this is a polynomial, so it probably actually keeps going down after that, I would hope. And we get rid of these rabbits that should not have been brought to this island, where they probably had some fragile ground-dwelling birds that were outcompeted by the rabbits or something. Anyway. Right. Okay, so that was the first one. And then the second one, what is the net change in population between 2 and 4 months? So we're just doing function value at the second time minus function value at the first time. And I'm just going to look back at my calculator and grab these values. Okay, so it's 1377.6 minus 1233.6. And I'm going to use a calculator and get that. And I'm getting 144. Okay, so then second question here is the average rate of change between 2 and 4 months. So you know the drill by now. This is your slope formula. Second function value minus first function value over second time or second x value minus first time or x value. So this is going to be 144 over 2, which I believe is 72. And so if we wanted the units for that, I think it's population over time, right? So it should be rabbits per month, which is a pretty funny unit. Okay, that's the end of this video.